joint OpenStack Israel and online meetup. We're very excited to start this partnership, and we hope this will be the first of many. First of all, thank you to everyone who showed up physically in Israel. Give a round of applause to all the Israelis in the house. And we'd like to say thank you to Raphael for helping facilitate this partnership. Today we're going to be talking about everything new in OpenStack Juno with Syed Armani from Hastexo, and we're going to tell some tales from the summit from the people who were there. Nati Shalom from Gigaspaces and Alex Friedland from Arantis. So let's get the ball rolling. Raphael, off to you. No, Raphael.
All right, guys, I was on mute, so apologies for the delay. Sharon, thank you very much for the introduction. There's not much to add from my side. I'm very excited to host this joint meetup with you guys in Israel physically and us online from all over the world. And just in case you have any questions that you would like to ask during this presentation, if you are attending us online, please post your questions in the chat window, which is on the left-hand side of your panel. And if for all those of you who are attending physically the venue in Israel, Sharon will collect the questions, and we will pass them on to the presenters after their parts. And with that said, let me hand over to Syed Armani from Hastexo. Syed, the stage is yours.
Thanks, Raphael. Hello, everybody. I am Syed Armani. I work as a senior consultant with Hastexo. And today I'm going to cover a little bit about what's new in OpenStack Juno. So over 1,400 developers from more than 130 companies were involved in the Juno release, and around 342 new features along with 3,200 plus bugs were fixed in Juno cycle. So that's a lot of work, which was the main focus of this release was basically stability and making rolling upgrades easy. And there was also a focus on the NFV side of things, especially on the compute side as well as on the network side. So the focus was basically on making these virtual machines highly performant. How many people know here what is NFV? Okay, that makes me interested in letting you know something about NFV. It is the new buzzword. So NFV stands for Network Functions Virtualization. So it defines the replacement of physical hardware appliances like load balancers, firewalls, and caching and gateways with high-performance software appliances running inside virtual machines, which are also known as virtual network functions. So there are some NFV requirements. So if we are going to push these virtual network functions inside OpenStack and we want them to run effectively, so we have some requirements there are some changes that need to be made in almost all projects of OpenStack. So in order for these VNF to perform correctly in a cloud world, the underlying infrastructure needs to provide a certain number of functionalities, which range from scheduling to monitoring and high availability. So this means that we need high performance from many OpenStack projects, especially from compute side and from the network side. So there was some initial work done to realize this. And in the Juno release, on the network side, we implemented 3 blueprints. The first one was supporting multiple interfaces from one VM attached to the same network. Sometimes you have these VNF functions running in a virtual machine which requires multiple VIFs. Till now, Nova didn't allow you to add multiple VIFs from the same virtual machine which are belonging to the same network. But now you can have as many VIFs attached to the same network in a single virtual machine as you like. The second thing was related to single root IO virtualization ports. This is a kind of very interesting thing. A Neutron port is either attached to a Linux bridge or it is attached to a OVS bridge. But with SRIOV implementation, this bridge will no longer be required. Instead, the SRIOV port is associated with a virtual function that is supported by the VNIC adapter. That means that you will directly go away with this bridge plus the kernel plus the host operating system. The packet will directly flow from DMA to the virtual NIC that is being offered via PCIe bus to your virtual machine. That will increase the performance of network performance tremendously.
So 1 second here, just for those who are not familiar, this is a pretty important feature. Basically, it means that you could go directly from the user space in the operating system directly to the NIC itself, without going through all the layers that you have to go through before, which is especially, I think, important both in virtualization environment, which is where NFV lives, and also in nested virtualization. So those who try to run nested virtualization experience a lot of differences in behavior when you're running a VM within VM. Part of that was because of the I/O performance related to the lack of SRIOV support. So this is basically the thing that allows you to bypass all the virtualization.
Syed, if you don't mind just repeating that, because closer to the mic and they didn't really hear it. So in short, what he just said a little bit louder. Sit there.
Yeah.
Go ahead. Okay. And the third thing that we is allowing Open vSwitch to use patch ports instead of vEth pairs for VLAN. So the thing is that right now in previously what used to happen that OVS used to, when you are implementing OVS plugin, you were using vEth pairs for connecting these bridges. The thing is that Intel DPDK accelerated vSwitch don't support it. So if you want to use Intel DPDK virtual switch, it's a software, okay, which increases the performance, network performance tremendously. So if you want to use these, you have to do something, do away with the vEth pair, and you have to use patch ports instead. So this change was pretty important, and it was implemented in Juno Release for making OVS to use patch ports instead of vEth pairs. Now that was.
Ask a question regarding the last one.
Yeah, sure.
So you can choose to implement an Open vSwitch with the DPDK acceleration,
and
or is it the Open vSwitch standard way without the DPDK?
It will depend on what kind of underlying infrastructure you are having, and in case your patch ports are not supported, okay, by the infrastructure, then it will default to vEth pairs. Then OVS will tend to use vEth pairs as it was doing previously.
Syed, I'm just going to have to ask you to repeat the question. That's okay?
Okay.
Just repeat the last question. Repeat them so everyone online can hear them.
So these are the changes on the network side related to NFV. Now I'm going to touch about the changes in compute side. So the first one, this feature aims to give users and administrators the ability to control vCPU topology. Basically, both of these blueprints were meant to for effective utilization of compute resources and for increasing performance. Because in NFV, the main thing is increased performance, high performance. And so these were the basic things of founding steps taken towards the integration of NFV in OpenStack. If you want to, there are various other blueprints which are targeted for the Kilo release, and there are a lot of things coming in Kilo which will enable the ease of deploying NFV workloads in OpenStack environments, OpenStack cloud. There is work needed on high availability and elasticity and many other things. There is a NFV team working group which is working on documenting the requirements and submitting blueprints, and there are teams working on it and implementing these blueprints and contributing code. Now let me come back to Nova core components, Nova scheduler. So Nova scheduler, there's a blueprint that was scheduled, targeted for Juno Release. Find, host, and evacuate. So now you earlier used to do Nova evacuate, name of the instance, and you have to give the name of the host where you want to evacuate this particular instance. But now you can do away with the host name. You just do Nova evacuate and name of the instance, and then scheduler will decide a suitable host for you, and it will migrate that instance to that particular node. One thing to note here, it's not live migration, it's a dead migration. So evacuation is basically used when your node is dead. Second thing is that Nova scheduler code will be pulled out of Nova code base, and a new separate Gantt project will be created. So for providing scheduler as a service, a generalized component for OpenStack projects. Something related to Nova networking. So Nova network was unfrozen in Juno. It was basically to allow parity between Nova network and Neutron, such that when and if Nova networks get deprecated, so it will be easy for operators who are running a Nova network right now to migrate their workloads to Neutron. And there was a change in Nova network code to allow per network settings. There were 4 additional fields which were added to the network table. MTU, DHCP server, share address, and enable DHCP. So they can have parity with the Neutron. And in terms of Nova itself, now Nova allows you the instance to be booted with single root I/O virtualization Neutron ports. It's very important that your host and your hypervisor should be aware of these single root I/O virtualization ports. So there were changes in the Nova code base related to the networking part. And also allowing virtual machines to attach multiple interfaces to one network, so that you can have multiple VIFs attached to the same network to a single virtual machine.
So just to be clear, the plan is still to replicate Nova network and move to Neutron. It's just that they added more feature parity into Nova network so that the switch will be easier feature-wise.
That's right. Switch will be easier.
So Neutron network is still superior performance?
So there's no, there's the Neutron network still with superior performance.
Nova network.
Oh.
Neutron.
Is Neutron is still superior?
Yeah.
No. In my humble opinion, Nova still does not. Neutron still does not have feature parity with Neutron, because they have implemented DVR for multi-host, but if you know that a DVR is marked as experimental, the DVR blueprint distributed virtual router in Neutron. So maybe in Kilo, or maybe in next release, I don't know.
Remind me to repeat the question. Sorry.
The question was that if Neutron is is better in terms of performance as compared to Nova network.
And if I'm a user, do you have any recommendation which one should I use, the Nova or Neutron? A new user of OpenStack?
Well, definitely you should use Neutron, because Nova network is going to be deprecated, but you have to figure out what the underlying plugin you want to use. So by default you have a OVS mechanism driver, but you can choose Linux Switch, you can choose VMware NSX, you can use Juniper Urban Control. It's up to you which plugin you want to use for better performance. Changes related to OpenStack dashboard. The most important highlight in the development of OpenStack dashboard horizon is the integration of web front Sahara. Sahara is the data processing service in OpenStack, which is very new. Sahara automates the provisioning and management of big data clusters using Hadoop and Spark. And according to OpenStack Big Data Analytics, Big Data Analytics was a priority for many organizations and a popular use case in OpenStack.
I'm going to touch more about it for now. I'll do myself.
And in Dashboard, we also OpenStack in Juno. We had some new features related to Neutron, like we have DVR support in Dashboard. We have L3HE support, and we also have IPv6 subnet modes, RA mode, and address mode support. Then there was better support now for Cinder API in Horizon. So now you can do enabling of resetting the state of a snapshot and enabling the resetting the state of a volume, supporting upload to an image, uploading a volume to an image, and then using it in glass, and then quality of service support, enabling how much bandwidth you want to utilize for a particular block device.
There's one question, Syed, from the audience in the online part of our meetup. Can you do a quick comment on what Sahara is for Horizon?
The question is about Sahara and Horizon. What does it mean?
Well, in Horizon, you get a nice graphical user interface, a tab for data processing, in which you can specify the template and you can specify your virtual machine configuration, and you can basically manage your Hadoop clusters for running your Elastic data processing jobs from the Horizon itself.
I will show the actual screen on my slides later on. Good.
All right. So the next thing is OpenStack Keystone. What's new in OpenStack Keystone? The first thing I would like to touch upon is keystone to keystone federation. So there were multiple use cases for this thing. Like Sun is running their private cloud, and they want to use public cloud providers for running their workloads. So how their existing users can authenticate against these public endpoint identity endpoints. So basically, they want to act as just as a identity provider and want to add these public clouds as service providers. And there are other use cases like cloud bursting. There is a company which, just like eBay, there's lots of, they are going to have a new discount sale, and they are expecting that, okay, we are going to have a lot of work. There will be a spike in load, so they might be able to use the service providers to auto scale in case there is a spike in load. So there are various use cases for this thing. So you can think of this something like this. Beta is the service provider, and Acme would like to use Beta's resources. So Acme here will be acting as the identity provider. So to establish a relationship between the two, Acme would trust Beta as a service provider. Acme is the identity provider, Beta is the service provider. So Acme will just trust Beta as the service provider. And Beta would trust Acme as the identity provider. So this will allow Acme to burst into Beta cloud, but this will not be other way around.
It's like impersonations in a way.
So it's something like enabling single sign-on and then using hybrid cloud, but both based on,
So basically it means that I can, sign into my OpenStack environment, and the fact that I'm using, let's say, hosted compute nodes that are not physically on my OpenStack environment, or somewhere else, that would still be transparent to me.
Yeah, then the keystone will just act as the identity provider.
Right. Okay.
Okay, and the next thing is that PKIZ is a new token provider for PKI tokens, because the maximum header size between a HTTPD and WebD process was fixed at 8 kilobytes. So they have to just, it's basically compressed form of PKI tokens.
because with a sufficiently large catalog, the token in PKI format won't fit, so compression seems like an easy solution. Then you have multiple identity backends. So you can have LDAP a Keystone having an LDAP backend plus for existing users, and you can have MySQL for new users. Neutron. So in Neutron, there were a couple of nice changes, like there was DVR was implemented for some. This will bring Neutron in feature parity with Neutron. Nova network with Nova network. I'm sorry. It will bring Neutron in feature parity with Nova network, because now we will have the routing as distributor. So in Neutron DVR, it implements L3 routers across the compute nodes. So all the compute nodes will have L2 agent running in DVR mode plus the L3 agent. So all the east-west traffic will not go through the router, because, for example, you have a VM1 running on compute node 1, and if it wants to send a packet to VM2 running on compute node 2, but they are two different networks, so they have to go through a router. Okay, so but now
there's one question, Syed. Sorry to interrupt you, Syed. There's one question from the online audience. Is Keystone to Keystone Federation means private to public cloud connection?
Yes, it is possible. Okay. And so yeah, east-west traffic. So VM1 running on compute node 1 can forward packets to VM2 on compute node 2 without going through the your router. So this removes the bottleneck of all the traffic flowing through your network node, okay, which was responsible for all the routing. Plus, you can have floating IPs attached to these virtual machines, and the north-south traffic will directly then go out from these compute nodes. So, but still, the default SNAP, if the VM does not have a floating IP, then still the traffic will go through the network node, and then it will go out. However, there's a catch with DVR. It's still experimental. It only works with OVS. It do not work with Linux Bridge at all.
Works only with
OVS, Open Vswitch. And also, Neutron Distributed Virtual Route DVR implements the floating IP namespace on every compute node where the VMs are located. So in this case, the VMs with floating IP can forward the traffic to external network without reaching the network node. So directly it will go out from the computer. This makes it the necessity that every compute node should be having an extra bridge X and an extra NIC that has external connectivity.
So that means that I can create a flat network as well using that mechanism, like without routers, without configuring routers, or touching routers, like I did with Nova.
I'm not sure. Not sure if you can.
Right now, the main change is that I have to configure a router and attach.
The thing is that what will you do if your virtual machine does not have a floating IP? Mm-hmm. If the VM only has the just private IP, then all the traffic will still go through the network node, the routing region, and then it will go out. So this is a work in progress, but maybe in future. And then there was a better IPv6 support for joint networks, and VM has a unicast address identified uniquely in the entire network. There is no netting right now. Floating IPs are not yet supported, and if you are using only IPv6, then for metadata of the virtual machines, you have to use config drive. And
there's one question.
Go ahead, Rafael.
Okay, there's one more question from the audience. Nova Network, Neutron, NFV. There are many network-related components from Juno Release. For some small scale of private cloud, what is the recommendation for OpenStack networking?
What is the recommendation for small scale for networking on OpenStack for small scale of deployments? I think that's the question.
Okay. first you should use Neutron. Then in terms of plugin, it depends on you. If you see OVS, if you want to use OVS, it has like, the packet has to go through like 8 and 9 virtual interfaces, but it has some good features along with it. If you want to go with Linux Bridge plugin, it has 3 interfaces through which the packet has to go through. So I suppose that I've heard from people that the performance is better in Linux Bridge. But if you this is just for a very small environment. But if you are a little bit big, I would suggest you to investigate and find out a good solution by investigating the various plugins available in the market, as well as investigating these OVS plugin as well as Linux Bridge. If you are happy with the performance, you can go ahead with either Linux Bridge or OVS. Otherwise, you can select any vendor plugin.
And they're listed in the OpenStack marketplace.
Yeah, you can check out in OpenStack marketplace. Okay, so yeah, let's talk about a little bit about high availability for the L3 agent. It was a problem till now, but now a basic solution was implemented using KeepAliveD, which is still not experimental for Juno Release. So this is implemented by scheduling a virtual router to more than one L3 agent. And the KeepAliveD is used for implementing these features. So KeepAliveD uses the IRP protocol. So there will be one router which will be broadcasting like, okay, I'm the master. It will have priority or something, and then there will be a slave which have less priority, and it will be the second router. So fallback, so slave. So if this router dies, then the routing machine will switch to another router. But there's some work going on for TCP connection, for maintaining the state of TCP connection, and they are planning to use contract read for that. So it's still marked experimental in Juno Release.
There's one more question from the audience. Can I assign floating IP as physical subnet IP?
Sorry, can I find?
Can you assign a floating IP? Can you repeat that, Rafael?
Yes. Can you assign a floating IP as a physical subnet IP?
Can you assign a floating IP to a physical subnet IP?
Physical subnet IP.
Was that the question? I think physical. So was that connecting a floating IP? Did I get it right? A floating IP to a physical subnet IP?
Yep, that's the question.
Okay.
I'm not sure it's possible. I'm not sure.
So we'll have to check it out, and we'll send the answers as a follow-up.
All right, let's move to Cinder. So there was a support for volume replication, support for consistency groups and snapshots of consistency groups, and the support for volume pools, and enabling the ability to restrict bandwidth usage on volume copy operations. There are many, some of these operations are mainly concerned with high-end storage backends that are available to you, like EMC, NetApp. They provide you like consistency groups and snapshot for write consistency and all.
One more question from the audience. Does the consistency group require Ceph?
What was the question again, Rafael?
Does the consistency group require Ceph?
No.
The answer is no. Go ahead.
OpenStack Heat.
Faster.
Okay. So OpenStack Heat implemented few neat features like recovery from failures during the stack updates. Earlier it was something like that. You did heat stack create command, and you could not, interfere in its operation. It will do its job, fail or pass, and then it will do it. Now you can recover from the failures as well. And API to cancel and roll back a in-progress stack update. And there are also new resources now available, so like Glance Image, and for also software deployment. In terms of OpenStack Database as a Service project, There's support for asynchronous replication, master-slave replication between MySQL instances. And there's a new clustering API support for MongoDB clusters. And earlier the support for deploying Flow was only with Nova Network. Now you can use Neutron for networking for your Flow instances. You also have support.
Trove, for those who are not familiar, Trove is the database as a service, the equivalent of Amazon RDS. Regulation on that. Yes.
No, it was introduced.
It was previously introduced there, but I think it became, previous to that it was a preview mode, something like that.
Yeah, so it became more stable in this release. And
yeah. It wasn't an official kind of feature.
So Marconi changed his name to Zafar, and the car is not integrated, it's still in the incubation phase. And there is a support for provisioning PostgreSQL data store instances. As you know that OpenStack Control does not limit itself to just one type of data store. Then
there's a question. There's a question regarding is any progress with Sender, Multipath, and Juno?
Could you repeat that again?
Yes. So the question is there any progress with Sender, Multipath, and Juno?
I think
Sender, Multipath.
It's Multipath. I think the last time I checked, the code needed review. I'm not sure if it's much.
Go ahead.
All right. So OpenStack Sahara. So it's a data processing UI fully merged in Horizon. Support for Apache Spark was added. Support for Apache Hadoop was added. Lambda integration was added. OpenStack Swift. Until now, all data within the set upon just 2 storage policies and Keystone VC support. So until now, all of the data within Swift cluster is evenly distributed across a set of disks, nodes, and data centers. But most likely not all the data has the same storage requirement. For example, you might want to store some data on a very fast SSD, and some data on a different data center or country, and yet other data using a different storage backend. So with that introduction of storage policies, it is now possible to choose different levels of replication, different types of storage. For example, fast SSDs or slower spinning disks based on performance and cost requirements, and also storing data in specific data centers or regions, which might be required by local laws. And there is also Keystone VC API support in Swift. So that was all in Swift. And I think I am over time. And thank you very much.